Good morning and welcome to today's presentation. Today's presentation will be on the Ocean County Justice Complex Combined Heat and Power Project and how they've received project funding through New Jersey's Clean Energy Program. The presentation today will be made by Paul Sweetwood of TMN Associates, the engineering firm that handled design and installation of the project. Today's webinar is brought to you by New Jersey's Clean Energy Program. My name is Andrew Farrell, an Outreach Account Manager from TRC, and I'll be acting as today's facilitator for the event. Also presenting today will be Michael Manter from TRC, an Outreach Account Manager for North Jersey. He'll be going over the Combined Heat and Power Program with New Jersey's Clean Energy Program and how to best utilize its incentives. We're going to let the presenters present in their entirety, and then once they're complete, we're going to go into any questions. So if you have any questions, please put it in the question box tab on your GoToWebinar control panel. We'll save those all for the end, so please type them in as we go through, or if you'd like, you can save them, type them in where we're in the question portion of today's presentation. Just a little background about New Jersey's Clean Energy Program. It is administered by the Board of Public Utilities Division of Clean Energy. The funding is through the societal benefits charge on your utility bill. A little information about that is every time you pay your utility bill, a portion of your payment is going to go into the societal benefits charge, which will fund our program. So anytime you get a Clean Energy Program incentive, it's like you're getting your money back. Some of our program goals are education, changing behavior, provide opportunities for NJ residents and businesses to reduce their energy costs and lower operating costs, protect the environment and lower emissions, and meet the governor's goal of 100% clean energy by 2050. This program helps strive for these goals set out in the Energy Master Plan. We're going to hand this over to Paul, and he's going to start today's presentation about the Ocean County Justice Complex.
Good morning, everybody. I'd like to thank everybody for taking the time out of their schedules to participate in these particularly challenging times. Today, we're going to be discussing the Ocean County Justice Complex Combined Heat and Power Unit installation. The project has been taken a number of years to complete and taken quite a large group of people to assist. This is quite an ambitious endeavor by the county to provide support and energy savings and clean energy. I just wanted to say that for any project of this undertaking, there's a lot of people involved, and this couldn't have happened without all of their cooperation. The owner, its employees, operating staff, the professionals, obviously the folks from clean energy, contractors, utility companies, etc. So it takes a large team to pull one of these things together, and I think that'll become apparent as we go through the presentation. The best piece of advice I can give to anybody before starting one of these projects is to make sure that the client is comfortable with the project before initiating it, because it's a long and so complicated process. So we're starting out with a quote from Ocean County Freeholder Vicari. Quotes allow for a more efficient and cost-effective way to control our heating and cooling units. Ocean County taxpayers will benefit from these upgrades as we reduce our energy costs. Costs for the improvements are being partially offset by the substantial incentives from the State Board of Public Utilities, and the money saved on energy could be reallocated to pay for additional energy upgrades. Clearly, the freeholders are well aware of the potential for energy savings, for cleaning the environment up, and for providing resiliency. So this was on the radar screen from the highest levels of the county government. So how did we get here? In the beginning, Ocean County decided to investigate installing a combined heat and power unit at its Justice Complex site at Hooper Avenue and Toms River in order to reduce its carbon footprint, reduce energy consumption and related costs, and improve the resiliency of the facility with respect to possible electric utility service interruption during a major storm event. This facility, which is an essential facility, considering it includes courtrooms, the sheriff's department, houses, jail inmates. It's a very, very important facility for the county. And during Superstorm Sandy, it was shut down for between a week and 2 weeks, which was a significant impact. So the resiliency element of this provided some special incentives for the county. Initially, a detailed analysis was performed for the facility to see if putting a combined heat and power system made sense. The detailed analysis resulted in the CHP system configuration and optimized energy performance and met state emissions criteria. It also defined an electric and thermal operating analysis of the plant, an installation budget, an estimation of the potential incentives, a financial model demonstrating the CHP related costs and savings, and a cost sensitivity analysis for higher and lower electric rates and natural gas costs. So that was all factored in at the early stages of the program. And again, that's some of what was reviewed with the client in order to make sure that they were comfortable with the program. General orientation of the county complex, the Justice Complex, which is about 160,000 square foot facility. That was the initial focus of the study. And as you'll see, some of the other facilities that were added include the new jail that was constructed is also 160,000 square feet, the existing West Courthouse wing, the existing East Courthouse wing, and the location of the combined heat and power unit is located adjacent to the Justice Complex. And some capital improvements were made also for a future building to be constructed at the parking lot adjacent to the Justice Complex. So that kind of gives a little orientation of where these facilities are. The county was also beginning the implementation of an energy savings improvement program at 6 of its downtown Toms River facilities, including the Justice Complex, jail, and courthouse buildings. It was then decided that the CHP project would be integrated into the ESIP, compounding the benefits of each program and allowing for more favorable loan arrangements. The analysis was updated to incorporate both loads from some additional buildings and an estimate of the energy reductions based on the planned ESIP improvements. The analysis included an in-depth review of utility company consumption information, field measurements, review of equipment manufacturer information, comparison to similar facilities, and other factors. The result of the analysis was the facility would be able to utilize a 600 kW natural gas-fired internal combustion engine. On the thermal side, from a waste heat recovery in the summertime, the system would drive a 120-ton absorption chiller, also supply heat to the building reheats, and provide heat for the domestic hot water systems. In the wintertime, the system would provide building space heat and also the domestic hot water system. Regarding the electric side, the system was designed to offset the base load electric utility import for the existing buildings. 3 separate meters and services serving the existing buildings were consolidated into one primary service to enable utilization of the 3 existing emergency generators and the new CHP as a resilience measure, and to enable behind-the-meter CHP interconnection. And an added bonus in terms of savings was that 2 of the buildings' meters were secondary service, and by switching them over to primary, there was also a savings. Some of the critical considerations for this particular application is that this is a secure facility. They've got courtrooms, the sheriff's department and jail facilities, all highly secure, not wanting people to get in and not wanting people to get out. It's active 24 hours a day, 365 days a year, making the actual construction challenging so that we didn't interfere with daily operations. Public access must be obtained. There are jurors, other personnel coming into the building at all times, so public access had to be maintained throughout the course of the construction. A lot of the courtrooms faced the CHP area, this is a designated area, so acoustics was a tremendous issue because in the courtrooms they record all of the sessions and they don't want to have interruptions from something that's happening outside. One of the other considerations is maintenance accessibility for urea deliveries, mechanical access, utility company access, all of those things had to be maintained. And the final critical consideration was that the CHP itself had to be installed in a secure area. So the acoustics is something that everybody's concerned about on every project, but in particular on this particular project, since like as I said, the courtrooms kind of faced the area where the CHP was going to be installed. You can see the photo in the lower left-hand corner is that there's a speaker that was set up in the vicinity of where the CHP was going to go. And the face of the building that you can see in the background, that's where the courtrooms are located. So this was a very critical concern that was handled earlier in the project to make sure that there wasn't going to be some sort of an issue here. So we had gotten some information from some of the equipment manufacturers on the ambient sound levels outside the unit. a testing company was called to come in and simulate tests. Measurements were taken inside the building. Kind of a brief summary is located in the upper right-hand corner of the slide, showing that there was virtually no change in sound levels inside the building during the simulation or when the simulation was not taking place. So based on these results, we felt very comfortable moving forward with putting the unit in that particular location. So after we've performed our feasibility analysis, we made application to the Board of Public Utilities Clean Energy Group, and filling out all the modeling information, we were predicting that we're going to have an annual system efficiency of around 76% efficiency. So this is one of the slides from that application process. Carbon dioxide savings will exceed 1,500 metric tons per year at about the equivalent emissions of about 300 passenger vehicles. So this is providing a greener option for the energy required at the facility. Some of the capital costs, always important information for the client. The project required about $3.7 million in hard costs and an estimated $1.2 million in long-term maintenance costs. So those are elements that factored into the overall financial analysis. Subsequent to the application, the Ocean County received a grant from the Board of Public Utilities in the amount of $1.1 million in incentives for the installation of the CHP system at the Justice Complex, which was a great opportunity to offset those first costs. After the initial incentive was awarded, the BPU came out with an additional incentive for Black Start, which had been built into this project. Therefore, we went back to the Board of Public Utilities, which subsequently awarded the Black Start incentive of about, if it was 10%, making the total incentive for the project $1.21 million. So as I mentioned earlier, there's a lot of people that are involved in a project like this that I'm sure this slide doesn't come anywhere close to identifying. T&M Associates was the engineer of record. The engineering feasibility analysis and feasibility study was led by Integrated CHP Systems Corporation. The acoustic analysis was performed by Lewis S. Goodfriends and Associates. Integration into the Energy Savings Improvement Program was executed by the ESCO for that project, which was DCO Energy. Procurement, there were separate contracts for the equipment supply from Foley Incorporated CAT. The unit was constructed and shipped from Germany, stored temporarily in North Jersey until the site was ready to accept the unit. The mechanical, structural, civil installation was by PJM Mechanical. The electrical service consolidated was by Kubiak and Sons Electric, and the building management control interface was by Unitem. So you can see there's a large number of entities that need to be able to integrate all of their services together in order to have a project like this be successful. So this is a schematic level of the system. I won't go into too much detail, but what the schematic represents in the green box is the CHP system enclosure. That unit, besides generating electricity, circulates glycol to the building to a heat exchanger, which is noted as heat exchanger number 1, HEX1. And then the glycol goes back to the CHP system itself. Inside the building, hot water is circulated to various heat utilizing components, including absorption chillers shown in pink on the right-hand side. The routing of the hot water heat recovery loop is shown in red line going through the building, and also provides heat to a series of heat exchangers that are located HEX2, 3, 4, and 5 at the bottom of the drawing. The way the system works is the water circulates to heat exchanger number 2 first. If there's enough of a thermal load that the temperature of the hot water drops below 170 degrees, all of the other heat exchangers are bypassed and the water flows back to the heat exchanger number 1. If there's additional thermal content that can be utilized that will not result in the temperature being below 170 degrees, the water can flow to the next heat exchanger, be utilized, and so on until all the heat, useful heat, has been taken from the system and the temperature has not dropped below 170. The water circles back to the heat exchanger number 1, is warmed back up again, and loops around again. So that's the general concept for how the thermal portion of the system works. So here are some slides of the finished product. The combined heat and power unit sitting outside on grade in the upper left-hand corner. On the left side of that slide, you can see some of the glycol piping that runs off toward the Justice Complex. The lower left-hand corner, you see the engine that's connected to the generator inside the unit. The center picture once again shows from a higher level the CHP system in operation. You can see the stack and the exhaust from the stack. You can see the piping once again going across toward the Justice Complex from the side of the unit. And then finally, on the right-hand side, there's a ground level picture of the CHP showing the installation at the parking lot area. Some additional details, once again showing the glycol piping that's extending from the CHP toward the building, and also the power conduits and the shore power connections and control conduits that run between the building and the CHP on the upper left-hand corner. In the lower left-hand corner are those same connections that are connecting to the building. Immediately on the inside of the building in this photograph is where the heat exchanger number 1 is, which is taking the thermal from the glycol and exchanging it to the hot water loop on the inside of the building. And then the glycol is routed back out to the CHP unit. The center slide shows one of the hot water circulating pumps. We have two. One's a standby for the system. Upper right-hand corner is the new centralized electric service that provides power to the buildings being served, the Justice Complex, the jail, courthouse building, and an additional cubicle was installed to provide power at a future point in time to the building to be constructed on the adjacent parking lot, thereby saving some capital costs at the time and also being able to provide primary service to that particular unit. In the lower right-hand corner is a typical heat exchanger. This is actually heat exchanger number 2. It's a small portion right in the middle is the heat exchanger. They're fairly compact devices with a lot of piping connected to them. And there's 2 of these lines represent the glycol piping, the hot water piping providing heat to that particular system. And this one is actually serving the domestic hot water. So 2 of the pipes leading away from the heat exchanger are carrying the hot water that's going to be used to distribute to the building. So this is a brief video showing the operation. I hope it works. Maybe a higher level view of how the systems are connected together. Next slide. This is another ground level view, the same thing of the unit operating. Get an idea what the aesthetic impact is, which is fairly low. All of the data being collected for the system is being collected in the building automation system for the facility. This is a graphical representation of the system. You can see in the upper left-hand corner is the combined heat and power unit, circulating glycol to heat exchanger number 1. Also being circulated to heat exchanger number 1 is the hot water that circulates through the building and is supplied to various thermal end users inside the building, such as the absorption chiller, various heat exchangers that provide thermal energy to the domestic hot water system and the building heating systems and the thermal reheat systems in the building. So the building automation system is set up to collect information that's relevant to the operations of the system, including providing feedback to operators on the status of the system, also providing a documented record of the energy consumed and the energy produced that ultimately will be provided to the Clean Energy Department to substantiate the performance after 12 successful months of operation. So that data has been set up to be something that can be utilized for evaluating the performances of the equipment to make sure that everything is working as it should be. And all of this was integrated together with the various pieces of equipment that were utilized for the project. So this is one of the pieces of documentation that's generated by the system. We're tracking the fuel input in the blue line, the electrical output in the purple line, thermal output in the deep blue line, operating time and efficiencies. So this is a typical type of data that we're graphically able to look at for snapshots in time to make sure the systems are working correctly. It's also being logged in spreadsheet type form for subsequent submission to the Office of Clean Energy. And that's really about it. The system has been operating since December 3rd. It's been operating pretty much full time since then. And there have been some shutdowns for periodic maintenance, but right now we're running at about 90% of the time it's been operational. The operating staff have been patrolling and taking a look on the inside of the unit, getting familiar with it so that they get more comfortable with the operation. That was something that was started early on in the process. So there's been a lot of effort in trying to integrate all the personnel together into the program. And that's really what I have, and then I'll answer any kind of questions that I can.
Thank you, Paul. That was very good. I have a couple questions that came in during the presentation. One is, how did New Jersey Natural Gas help with the project?
New Jersey Natural Gas was actually very helpful during the course of the project. Not only were they helpful because they had a main line that ran right by where our installation was, which was very good forethought for them, but they also helped us with our connections, orchestrating how that was all going to take place. And once the system became operational, the county, like many other entities, procures their energy sources from third-party vendors. And once we had a track record, they recommended to us that we move the load over to the third-party provider, such that some of their distribution costs would be reduced. And the county was able to execute that, which ended up resulting in an additional savings of about $40,000 a year. So Craig Swalick from New Jersey Natural Gas was a very helpful partner in this whole process, as were the people at the electric utility. This was, again, this was a team effort from the very start, and everybody wanted to see it succeed, and I think with all of their assistance, it has.
Thanks, Paul. Another one that came in was, how does the CHP system operate in a situation where the utility is down and emergency generators are running?
That's a very good question, and that took a lot of coordination, particularly by our electrical engineers. The system is designed such that if there is a power outage, the county personnel will make their best determination. Does this look like it's going to be a protracted outage, or is this something that's going to take an hour or 2 hours? If it's a brief interruption, the system shuts itself off when the utility power goes off. And once power is restored, the system gets turned back on again. If it looks like it's going to be something where it's going to be several days out of commission, and the county wants to make sure that the facilities are operational, we have a black start procedure whereby we disconnect ourselves from the utility. We go into an island mode, and the systems within the building, it takes about an hour, are turned back on again, such that the entire facility between the CHP and the standby generators will be fully operational. So that's taken quite a coordination effort, but utilizing a lot of existing controls in several different vintage buildings. But it worked out very successfully, and we've dry run that scenario, and it's worked effectively. So, but yeah, the system does turn itself off upon loss of utility power, which is as required by the utility companies, and is turned back on again, under normal circumstances if it's a brief outage after the normal power has been restored.
Thanks, Paul. And then we have one last question. Was there a required payback for the incentive? So I think what they're saying is, was there certain standards you had to hit to get this incentive you received?
Yes, there were incentives that are outlined in the Clean Energy Program. This system had to have a simple payback of less than 10 years, which it does. And in fact, with the additional natural gas savings that we recently received, is probably somewhere in the 8-year payback period of time. Once again, one of the drivers for this particular installation was the resiliency aspect. It's very good that the county is going to be saving funds and the environment's going to be cleaner, but they could not afford to have another outage like they had in the past. So that was really one of the main drivers. And as long as all the other parameters lined up, the county was very enthusiastic about moving forward with this.
So actually, we just had a couple more questions come in. Would there be anything you've done differently in your next CHP project?
There probably are a few things that would be done differently. I mean, we did, and it was kind of necessitated by virtue of other factors that were going on, but there were a lot of entities involved in developing this, a lot of different contractors. The next project would probably be better if there were fewer different entities involved. Not that everybody didn't work hard and well together to coordinate things, but that was probably one element that took a lot of coordination and probably was unexpected in terms of how long it took to develop the project. The other thing is that the original shakedown period, to kind of get the system up and running, took a little bit longer than anticipated. That might have also been contributed to by the fact that there were so many different contractors and entities involved in the startup of the systems. But those are probably the two things that struck me that would probably be different. One of the things that we did, sometimes it's good to look back and see what you did right, because not everyone works out that way. And one of the things we did right, again, was engage with the client very early in the process, make sure that they knew what was going on, and engage with the clean energy people early. And that was, before we moved forward, making sure that we had a thorough understanding about how the process worked, what the expectations were, so that once again, we could let the client know that. So those were some things that were done early in the process that were very good to do. But I think that the one thing that if I could do it differently in hindsight, it would probably be somehow to have a more consolidated group of individuals that were actually building the system out.
You mentioned the project incorporated infrastructure upgrades. What were some of those infrastructure upgrades?
This project provided some opportunities for the county to make some other improvements kind of in parallel with these improvements. And for instance, there was they've got a courtyard, a central courtyard, where we were running conduits through to be able to provide power to the courthouse building, and that was going to get opened up. So they saw an opportunity to dress up this area that was in need of some aesthetic improvements. So that became another part of the process, was improving the overall access and aesthetics through their courtyard that separates the jail, the justice complex, and the courthouse building, and improve lighting. There were a lot of things that happened kind of at the same time as the rest of the CHP project. So there were some tangential things that happened. The consolidation of the electric service was another major factor. So there were a number of different things that took place that would made logical sense to do at the exact same time that these things. Also some internal electrical improvements within the building itself. So there were a number of things. And then piggybacking on top of that were all of the energy savings improvements program improvements that were going on at the same time, which was, it was important to integrate what this project was doing with those improvements as well. There was a new chiller put in, new cooling tower put in, a lot of other new infrastructure in the building. So this job had to coordinate with all of those elements at the same time.
Great, thank you very much, Paul. Right now, we're going to turn it over to Michael Manzik, who's going to talk a little more about the Combined Heat and Power program.
Thank you, Paul, for a very informative presentation. This is quite a success story, and I'm pleased to be able to share it. I'm also pleased that the program itself provided you with an incentive to help make this happen. One of the things that the Clean Energy Program offers is distributed energy programs for combined heat and power, and also fuel cells. The actual requirement is that a commercial industrial customer, which, as you know, includes municipalities, counties, any kind of public entity which maintains a general service type of an account, whether it be secondary voltage, primary service, or transmission level service as well, may require on-site generation. They may either require waste heat utilization or not utilize that waste heat, topping or bottoming type of projects. The key is not so much on the size. Now, as Paul described, this was a 600 kW system designed to supply cooling, heating, DHW as well as facility power, there's no minimum type size requirements typically. What is required is it must pass its cost effectiveness test, and it must run an equivalent of 5,000 full load hours per year on an annual basis, 3,500 for critical facilities, such as this would have been determined to be a critical facility. Now, the actual key to understanding what the CHP is about is that, as Paul described in quite good detail, is that it will generate electricity and it will also provide for waste heat to be used, to be captured and used, okay, not just vented off through the atmosphere and provide environmental degradation. The big benefit here was resiliency to the county with a return on investment, as he said. An 8-year payback is pretty significant when you get into a capital project of this magnitude. One of the things that the New Jersey's Clean Energy Program, distributed energy incentives is that they're technology neutral. Okay, it's not going to require that you do a microturbine, not going to require that you do solar, it's not going to require that you do anything specific other than the fact that it provides for some type of generation. And most recently, now you can get into the fuel cell aspect of it as well over the last couple of years, with or without heat recovery. So typically, fuel cells have been without heat recovery, and that's been an issue of conversation, shall we say, at the state level for a number of years. Typically, combined heat and power or fuel cell with heat recovery is going to have a project cap of between $2 and $3 million in terms of the incentive that's provided. As Paul described, this particular facility has the black start / islanding capabilities and was able to receive a critical bonus, a bonus for additional capability. In addition, if this were to be something using biofuel, it might have been incentivized with another 30% incentive bonus as well. If you take the heat recovery aspects out of a fuel cell type of an installation, your cap is lower to $1 million on an annual basis. This eye chart is not designed to test your ocular capabilities at this point in the morning, almost noon. However, just to give you a sense that it can be a topping or bottoming type project. We can look at gas internal combustion engines, combustion turbines, microturbines, fuel cells with heat recovery, without heat recovery, waste heat to power, garbage type of plants, okay? Depending upon the size of the rated capacity, it's going to vary. The incentive is going to vary in terms of dollars per watt. And there's going to be a total percentage of the project cost that it's going to apply for. And again, as we said, it typically is going to go between $2 and $3 million per project. If in fact it's fuel cell without heat recovery, that cap is $1 million per project. And as noted by the asterisk at the bottom, there is a critical facility black start bonus of 25%. I just wanted to thank everybody for your time and attention today. If you have additional questions, you can please feel free to give me a telephone call or an email. You can also connect with us on our website, njcleanenergy.com. If you're not subscribing to our newsletters already, please do get on our listservs. And we look forward to hearing from you and seeing you at future webinars. Again, thank you for your time and your attention today. Andrew, I guess there's no more questions.
We do have one question that came in.
Oh, good.
How much funding does the program have through the end of fiscal year 20 and into fiscal year 21?
Okay, that one I'd have to look up, okay, at this point in time.
Okay.
Don't remember off the top of my head.
Okay, and then we have another question that came in. Are New Jersey Clean Energy Program incentives for non-IOU too? Or what if I have a municipal utility?
Okay, if the municipal utility, as you know, they typically I can say this, a municipal utility does not pay a societal benefits charge into the rate structures which fund these programs. Okay? So unless there's another service which is funded perhaps by a gas utility, and that gas charge do include societal benefit charges, they would not be applicable to this type of program. There are state energy program funds available for smaller customers for different kinds of programs. We can talk about that offline. But if you're a customer of a municipal electric utility, typically you're not qualified for electrical programs with clean energy program. If you're a gas customer, you qualify for gas programs alone. Okay?
one more question that came in. If I'm doing a CHP project, can I also have other New Jersey Clean Energy Program incentives that come through? So like, can I change out my lighting when I get my CHP done?
I would certainly look to get that understood before you go and size your project. I mean, if you can minimize the load you have to generate, and Paul, you might want to comment on this as well. If you can minimize the load you have to self-generate to provide for your electrical requirements, you're better off doing that at the beginning. And yes, you can use programs like Smart Start Buildings or Direct Install, perhaps even a local government energy audit if you're far enough ahead of the curve in terms of the schedule to get a sense of what your project's going to look like. I would guess a lot of that was done by the engineers when they sized the equipment to begin with.
Yeah, that's exactly right, Mike. You know, when we initially looked at the CHP, it was just for the Justice Complex. And then, as I mentioned, the Energy Savings Improvement Program came along and the two were married together. And when we did our analyses and took into account the additional loads from the additional buildings, at the same time, we also made assumptions about how much less energy they would be consuming as a result of the improvements that were going to be performed during the Energy Savings Improvement Programs. And a majority of those improvements were lighting improvements. So those two programs did work together in this particular instance.
Good, awesome.
And I'd like one more thing with that. For any future information you need about any of our other programs, you can check out the Clean Energy Learning Center. All of our webinars, just like this one, will be posted as a resource to learn more about the program, see how you can get your best incentive out of there. And of course, you can always contact an account manager like Michael Manzik or myself.
Okay, one last thing too, Andrew. I just double checked on the program status in terms of how much funding was available. The website shows current as of December 2019. So I'm not sure if I'm comfortable giving out these numbers at this point in time. Just to let you know, the remaining budget for fiscal year 20 at the end of this past year was almost $5 million. But there was a number of projects in the queue. We're talking about like a little more than 50 projects, looking at over 26 megawatts of capacity in development. So a fair amount of incentives out there are being utilized, but and with a little bit left in fiscal year 2020 at this point in time. But again, as I said, this information is a little dated. I haven't seen it's updated. I don't have any access to the updated information. So you can always give me a call and I'll drill down for it if you need it. Need that.
And I believe all of our programs remain fully funded to complete fiscal year 20, which has been extended. So for more information on that, you can check out our website or talk with one of us. We do have one more question, Mike, if you have time for this one. It's for small CHP systems. If it's under 100 kilowatts, the 10-year payback period is 2 honors. Is there something the New Jersey Clean Energy Program considers when determining payback thresholds?
Well, I think the efficiency is probably one of the key considerations. It has to have a minimum 60% higher heat value heating efficiency. Again, if that 10 years is with or without the incentive, I'm not sure what the economics are for the particular system in question. So give us a call. We'll take a look at it. We can set up I'd be happy to set up a conference call with our technical engineers who provide the assurance and the assistance with the actual application. It helps to have help is all I'm suggesting. Give a call and we can look at it in greater detail.
Okay, thank you, Mike. So that concludes the questions right now. So we want to thank everyone for attending this webinar, and thank you again for Paul and Michael for presenting. If you have any further questions, please contact us at outreach@njcleanenergy.com or reach out directly to Michael Manzik. We want everyone to stay safe and have a great day. Bye, everyone.
Thank you.
Thank you, Andrew.